For today's lesson, we are going to learn how to use reference angles to evaluate trigonometric functions of any angle. To get started for today, in our warm-up section, what I want to do is I want to actually explain what a reference angle is. And what a reference angle is it's an angle that talks about what category other angles fall under. So when we were learning about the unit circle, we put certain angles in quadrants 2, 3, and 4 into the category from quadrant 1. For example, we learned that 150 degrees, 210 degrees, and 330 degrees all fell into the 30-degree family. And that 30 degrees represents the reference angle that we would refer to. And so the reference angle for an angle theta is the acute angle theta prime. So we read this as theta prime. And the way that we write it is it's with theta with an apostrophe. So it is the reference angle for theta is the acute angle theta prime formed by the terminal side of theta and the x-axis. So it's very, very important that you note that it is with the x-axis. So that is absolutely imperative. And so let's go ahead and draw a quick picture of what I mean by that. So if we were to draw any sort of angle, and I'll just make it in quadrant number 2 just to show you what's happening. So here's my angle. It's located in quadrant number 2. We'll call it theta. And in order for us to come up with what our theta prime is, or our reference angle, we are asking ourselves, how many more degrees do you need to travel before you reach the positive x-axis? This angle right here is called theta prime. It is an acute angle that represents a distance that a terminal side is away from the closest x-axis. And so this is our reference angle. It's always with the x-axis, never with the y-axis. So we're only working with 180 degrees in pi or 360 degrees in 2 pi. Now, reference angles relate to the given angle to its corresponding angle in the first quadrant. So like I was mentioning, 150 degrees, for example, corresponds to the 30-degree angle in quadrant number 1. They will have the exact same ordered pairs, it's just the signs will be different. Likewise, the degree 240 degrees corresponds to 60 degrees, and that's because they have the same exact ordered pair, just different signs. Now, the relationship between theta and theta prime for non-quadrantal angles of theta are shown down here. So if we were to look at quadrant number 2. So we have theta that's located in quadrant number 2. And if we wanted to find its reference angle, it is the distance that you have to travel further in order for you to get to the x-axis. So here's theta prime and here is theta. I don't really want you to think these. You're basically just asking yourself, how many more degrees do you need to go before you reach 180 or pi? So that's how we filled out our unit circle. We would go all the way to 180 and back it up at X amount of degrees. And so the same exact idea is just how much are you backing it up? So theta prime is basically 180 minus theta. And that theta right here, remember, is your given angle. But don't focus on the formula so much. Just kind of think about what is actually taking place. Let's go ahead and look at quadrant number 3. So if your angle lands in quadrant number 3, so here's where theta is, you're asking yourself, how far away is it from the closest x-axis of 180 and pi? So remember, in quadrant number 3, we would go all the way to 180, and then we would add a little bit more, and that little bit more that's your theta prime. So in order to come up with this, you would take your given angle. If you wanted to have a formula, which, like I said, don't focus too much on the formulas, you would take your given angle and you would add or subtract, you would take your given angle and subtract 180 or subtract pi, and what's left over will be your theta prime. And if you have an angle that lands in quadrant number 4, you're asking yourself, how much further do you need to go before it reaches 360 degrees or 2 pi? Because that's where the closest x-axis is. And so that is what your reference angle would end up being. So the formula, if you want to look at it as a formula, would be that theta prime would be 360 minus your given angle. So don't think about going all the way to 360 and backing it up, or all the way to 2 pi and backing it up. Whenever you back it up, that is going to be your angle. So reference angles have a couple of rules, and I want you to write down these rules. So I'm going to write down that reference angles that we call theta prime have two rules to them. Number one, they are always positive. They're always a positive number, and that's because they represent a distance that the angle is away from the x-axis, the closest x-axis. So that might be 180 degrees is the closest x-axis, or if you're in quadrant number 4, then that would be the 360 degrees. The second rule for reference angles is that they are always acute. So always positive and always acute. So I want to make sure that I emphasize that. Reference angles are always positive and always acute. So that's very, very important. Let's go ahead and look at example number 1. In example number 1, we want to sketch the angle that's given to us, and then we want to find the reference angle. So we want to sketch negative 165 degrees, just like we did a few lessons ago. So I'm going to label this using degrees, but going clockwise, 0 degrees, negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360 degrees. And then we always label or identify what our initial side is, and we are going clockwise and landing about right here. So that is theta. Theta is negative 165 degrees. Now, what I'm asking you is, what is the reference angle? The reference angle is how much further do you need to go before you reach 180? And hopefully you're looking at that and you're like, 15 degrees is how much further I am away. If you need to show some support, what you could do is basically take negative 180 and add 165 to it, because it lands in quadrant number 3, and you end up with negative 15 degrees. But because it's a reference angle, we take the absolute value of it, and our answer is positive 15 degrees. The truth be told, I do not need to see any work for theta prime. As long as you are able to give me the correct positive acute angle, we are good. You do not need to show this work, but that's essentially what we did in order for us to come up with this answer. All right, let's go ahead and look at letter B. Letter B this is in radian mode, and we want to plot 7 pi over 4, which is on our unit circle. But so I have 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. And I'm labeling this counterclockwise because my angle is positive. Now 7 pi over 4 is almost 8 pi over 4, but not quite. So it's landing in quadrant number 4. So that is theta being 7 pi over 4. So you're asking yourself, how much further do you need to go? Now, because this is in radian mode, our theta prime is also going to be in radians, and that is going to be pi over 4 radians away from the closest x-axis. Now, what's really cool about radians is that there is a little trick, and your reference angle is always going to be pi over your denominator. So in this case, it's pi over 4. But if you want to show work, basically we're taking 2 pi and subtracting 7 pi over 4, which we need to rewrite 2 pi in a convenient way of 8 pi over 4 minus 7 pi over 4, and that gives us pi over 4. You don't have to show me this work, but I do want you to have that awareness of what it is that I am doing. So our reference angle that we are interested in is pi over 4. Let's go ahead and look at letter C. Letter C, we have 150 degrees. So I'm going to write 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. We always plot our initial side, and 150 is not quite to 180, so it's landing about right here. So this is theta, which is equal to 150. So the question is, how much further do you need to go before you reach 180 degrees? How much did we go backwards? And hopefully you're looking at this and saying, well, that was just 30 degrees. And I know that 150 is falls into the 30-degree category, which means that the reference angle is 30 degrees. If you want to show work, it's 180 minus 150, which will give you 30 degrees. But regardless, this is what your reference angle is, 30 degrees. Let's go ahead and look at letter D. Let's go ahead and graph 5 pi's over 3. So I have 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to plot my initial side. And this is 5 pi's over 3, which is almost 6 pi's over 3. So it's almost 2 pi, but it lands about right here. So it lands a little short of it. And that is what theta equals 5 pi's over 3 actually is. So we're asking ourselves, how much further do we need to go in radians? So if we start with radians, we end with radians. We start with degrees, we end with degrees. And in this case, we're going to end up with theta prime being pi over 3. And once again, we get to use that beautiful trick of a pi over a denominator. That is what our reference angle is. All right, let's go ahead and move on to the next page. And one of the cool things is that you don't necessarily need to, especially with the ones that are on our unit circle, if you have like a gauge or an idea of what type of angle or what each angle that's given to you is, you can pretty much evaluate any trig function that's on the unit circle. So what we have here is evaluating trigonometric functions, and I have all of our signs. So you can use the unit circle to help you evaluate trigonometric functions without a calculator. Now recall that the unit circle contains angles between 0 and 360 and 0 and 2 pi. And so what I want you to do is I want you to make sure that you know all of your signs. And we have a little phrase, and that phrase is all students take calculus. And what that means is that all of our trig functions, sine, cosine, and tangent, as well as their reciprocals, are all positive in quadrant number 1. In quadrant number 2, just sine and its reciprocal are positive. Cosine and tangent and their reciprocals, they are negative. So only sine is positive in quadrant number 2. In quadrant number 3, only tangent and its reciprocal of cotangent is positive. Everything else is negative. So that's tangent is positive. And then finally, we have calculus. Calculus means that cosine and its reciprocal of secant is going to be positive. So that is cosine is positive. So all students take calculus, and we've already talked about that before. So now what we're going to do is we're going to use this knowledge along with the first quadrant of our unit circle to help us to evaluate trigonometric functions for any angle that is on the unit circle. So the first thing that we're going to do is we're going to actually identify what the reference angle is. What category does that angle fall under? And then we're going to evaluate for that reference angle. So as long as you know that first quadrant, you should be good. Then what we're going to do is actually do like a quick sketch of where that theta value that was given to us, what quadrant does it lie in? And that's going to tell us what sign we are going to use. So just to make sure that we are all on the same page, I'm going to use this space to create a first quadrant. So here is 30 degrees, 45 degrees, and 60 degrees. And right at each of these, I'm going to write down that this is 30 degrees, this is 45 degrees, this is 60 degrees, we have 0 degrees, and 90 degrees. Our radian measures, we have 0 pi, we have pi over 6, pi over 4, pi over 3, and pi over 2. And our ordered pairs that I need you to know, the ordered pair for 0 degrees is 1, 0. The ordered pair for 30 degrees is we're going over a long, up a short. So that's going to be square root of 3 over 2, 1/2. For 45 degrees, we're going over the same amount, up the same amount. So that same amount is square root of 2 over 2, square root of 2 over 2. And then we're going over a little bit, up a lot. And so that ordered pair is 1/2 square root of 3 over 2. And then finally at 90 degrees, this ordered pair is 0, 1. So if you, oh, and all of our tangents, sorry. So our tangent for 0, let me go ahead and put that in with a different color. Our tangent for 0 degrees is 0, and that, remember, is y over x. 0 over 1 is 0. The tangent for 30 degrees and pi over 6 is square root of 3 over 3. The way I remember it is if the denominator is 6, 3 plus 3 is 6. And also remember that when it comes to degrees and radians, a 3 does not match with another 3, okay, when it comes to radians. So 3 matches with a pi over 6, 60 degrees matches with a pi over 3. So I just want to put that out there. 45 degrees, the tangent is 1. The way we remember it is 2 over 2 is 1. And then we have 60 degrees, pi over 3. The tangent is square root of 3. And then the slope of a vertical line is always undefined. So we have all of the information that we need of first quadrant to help us to evaluate for example number 2. So in example number 2, we want to evaluate these without a calculator. So I'm looking at negative 225, and I'm thinking back to our patterns day. And I'm thinking about what category would negative 225 fall under. And one of the things that we know is that 225 does lie on the unit circle. So does its opposite sign of negative 225. And because it ends in a 5, that means its reference angle is 45 degrees. So I'm going to think, what is the cosine of 45 degrees? Now, the cosine of 45 degrees is square root of 2 over 2. Now, this answer, therefore, the cosine of negative 225 degrees is either going to be a positive square root of 2 over 2 or a negative square root of 2 over 2. So positive or negative, that's what I have to figure out. So I'm going to identify what quadrant negative 225 falls under, because I need to answer this question. Is it positive or is it negative? So I know that negative 225, if I were to draw just a really quick sketch, I don't need it to be perfect, it's just a quick sketch. I know that I'm going all the way to negative 180 and then just a little bit more, and I am landing in quadrant number 2. And in quadrant number 2, cosine is negative. So therefore, my answer is negative square root of 2 over 2. So once again, I used my reference angle to calculate, and I know that this answer is either going to be positive square root of 2 over 2 or negative square root of 2 over 2. It just depends on where negative 225 degrees lies in. So because it lies in quadrant number 2, cosine is negative. Let's go ahead and look at the next one, letter B. For letter B, I'm going to use that trick that we just talked about on the last page, which is that the reference angle is pi over 3. So I'm going to calculate the cotangent of pi over 3, which we don't require you to have that memorized. So I'm actually going to use the reciprocal of tangent of pi over 3. Now that's one that I do have to have memorized, and that is square root of 3. So therefore, the cotangent of pi over 3 is the reciprocal of pi over 3, which is square root of 3 over 3. So that means that the cotangent of 10 pi over 3 is going to either be a positive square root of 3 over 3 or a negative. And that's what I have to figure out. Is this going to be a positive number or a negative number? It all depends on where 10 pi's over 3 is located. So let's draw a quick sketch as to where 10 pi's over 3 is. This is where coterminal angles is very, very helpful. So I'm going to write 10 pi over 3, and I'm going to subtract away a spin because I know that I'm going to be going around one full time. So I need to figure out how much more do I need to go. So I'm going to take away a 6 pi over 3, which is a very fancy way of writing 2 pi, and this ends up equaling 4 pi over 3. So I need to go 4 pi's over 3 more, and that lands right here in quadrant number 3. So in quadrant number 3, we have all students take calculus, which means that cotangent is positive. So if tangent is positive, its reciprocal is positive. So therefore, my answer is just as it's written. Cotangent of 10 pi over 3 is square root of 3 over 3. Let's go ahead and look at the next one. We have the secant of 300 degrees. Now 300, that 30 is divisible by 6, so that means that the reference angle is 60 degrees. Now secant is the reciprocal of sine, so I'm going to think the sine of 60 degrees. The sine of 60 degrees I know is the square root of 3 over 2. So therefore the secant of 60 degrees would be the reciprocal, 2 over the square root of 3. But I can't have a root in my bottom, so I'm going to rationalize this. And I end up with 2 square roots of 3 over 3. So therefore, the secant of 300 degrees is going to be equal to either a positive 2 square roots of 3 over 3 or a negative. That's what I have to determine. Is this positive or is it negative? That is the question. So it all depends on where 300 degrees is located. And we know 300 degrees is located in quadrant number 4. And in quadrant number 4, oh, I'm so sorry, I messed that up. The reciprocal of secant is cosine because every pair needs a co. Oh, forgive me all. So the cosine of 60 degrees, that is 1/2. So therefore, we just got a little bit extra practice of what we do not want. So just forgive me. Let me go ahead and kind of get rid of that. All right. So sorry, y'all. The cosine of 60 degrees is equal to 1 over 2. So therefore the secant would be the reciprocal, and that would be 2 over 1, which is just a 2. So therefore our answer is just going to be either a positive 2 or a negative 2. And since it lies in quadrant number 2, that means it will be positive because secant and cosine are reciprocals of each other. So we are going to work with 1/2 and 2. Please forgive me on that. Okay, so we have 3 team questions, and we're going to talk about those team questions the next time that I see you. And let's go ahead and look at our last question, which is our Frogbot question. And in this Frogbot question, it says the Frogbot is a robot that is designed for exploring rough terrain on other planets. It can jump at a 45-degree angle with an initial speed of 16 feet per second. On Earth, the horizontal distance d in feet traveled by the projectile launched at an angle of theta with an initial speed of v, which is in feet per second, is given by this beautiful formula of d is equal to v squared over 32 times the sine of 2 theta. Now, how far can this Frogbot jump on Earth? So the way that we come up with this is we know that theta is our angle that's given to us. It is 45 degrees. We also know what v is. They told us that v this time is a speed, and that speed is 16 feet per second. So we're going to let v equal 16. So d is going to be equal to 16 squared, plugging it into this formula, divided by 32 times the sine of 2 times 45 degrees. Now we've got to calculate 2 times the sine of 45 degrees. And we also know that 16 squared is 256 over 32 times the sine of 90 degrees. Well, we know what the sine of 90 degrees is. The sine of 90 degrees, if you think about it, 90 degrees is up here, and that ordered pair is 0, 1. And the sine of 90 is just the number 1. So our answer is going to simply be 256 over 32 times 1. And if you put that into your calculator, that you'll find that the distance that it can travel is 8 feet. And I believe that there might be one problem like this on your homework. All right, that is the end of today's lesson. If you have any questions over anything I talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.